A very good afternoon to all of you. Now we will proceed for session 3 of day 4, Deep Learning Models Using Medical Image Segmentation. It gives me immense pleasure to extend a warm and heartful welcome for this session to our esteemed resource person, Professor R.K. Agarwal, School of Computer and System Sciences and School of Engineering, Jawaharlal Nehru University, New Delhi. Professor Agarwal is a renowned academician with over 25 years of teaching experience and an impressive record of over 85 publications. He holds an MTech from IIT Delhi and PhD from University of Delhi. His research expertise lies in data mining, machine learning, pattern recognition, and medical imaging. Professor Agarwal has delivered 11 invited talks or lectures at international workshops, symposia, and conferences and over 170 at national level events. Sir has supervised 17 awarded PhD theses with 6 ongoing and 38 awarded MTech dissertations with 1 ongoing, and also a member of prestigious professional bodies IEEE and ACM. Professor Agarwal plays a pivotal role in shaping the academic frameworks, serving as a member of Curriculum Committee of CBSE, National Board of Accreditation, and National Assessment and Accreditation Council. Additionally, Sir has been a jury member for Inspire Award, National Level Exhibition and Project Competition organized by Department of Science and Technology, Delhi. We are truly honored to have you for this session today, sir. Over to you, sir. Sir has joined. Participants, we are just sharing. Participants, I think Sir got disconnected. He is joining shortly. Please wait. Uh, Sir, are you there? Professor R.K. Agarwal? Sir, are you there? Because we are not able to find you in the attendees list with your name. Could you please raise hand or write in the chat window? Because we have to make you a presenter. Aruna Tomar. Aruna ma'am? Faculty 31. Okay, fine. Ma'am, it is faculty 31. 31. Yes.
Hello. Am I
Hello.
audible?
Yes, sir, you are properly audible.
Uh,
Good afternoon, sir. Welcome, sir.
is this slide visible to all of you?
Yes, sir, visible.
So check it whether these are, can you see its movement?
Yes, sir. We are able to see the
Okay,
animations.
fine,
Thank you, sir.
fine. Okay, so thanks for the nice introduction. And I'll be talking on deep learning models for image segmentation. Okay, in particular, I'll be focusing on medical image segmentation. An outline of my presentation will be first, I'll be describing what is segmentation. Then I'll be talking about traditional, very simple method of doing segmentation. And the name of that method is thresholding method. And then I'll be discussing very briefly about multi-layer perceptron. It will be followed by convolutional neural network. And then we will discuss the main deep learning model, that is UNet. Okay, and its variants for image segmentation. And further, I'll be talking about one of the model which we have proposed with the name ITER-MUNet. Okay, and we'll be talking about experimental results and its discussion, followed by conclusion. So, what is segmentation? So, if you can see this picture, and you find that there are various objects present in this image. What are these objects? One of the object you can see is there are many trees. Okay. So this is one object. This is another object. This is a partial tree. So these are objects. Further, your background, sky is also an object. Your green land, grass. Okay. This is another object. Then you find there are many buildings around. So they are also objects. And the objective is that we can divide this image into many sub images, or we say sub regions, so that each sub region represent one kind of object. So after segmentation, we should get, this should be a sky. We should be able to get tree, one tree, another tree, then this partial tree also. Then we should be able to find out which sub-region forms grass and maybe background buildings. So we say that what is your image? Another example you can see. If you talk about this is a picture, and based on intensity color, we can see that we can divide this region into many sub-regions, where this forms your sea, while this forms a part of the sky. Then you have a sun, Okay, and then this is another part which is difference in intensity or color, and that forms another kind of object. Now you think about that you have an image which is capturing two different kind of pulses distributed in this fashion. So we can see that which region forms one particular kind of dal and which sub region forms another kind of dal. Okay, pulses. But can machine can divide this region into two sub regions, and we can say that okay, this sub region describe one kind of object and this sub region describe another kind of sub object. Okay, sub region. Okay, object. Similarly, you can think about that. Let's say we have captured satellite image, and in this image, you have various sub-regions where some regions describe roads, while some regions describe habitat area. And in this habitat area, you can have green belt. You can have some place which is where you have water bodies. So how there can be a machine learning algorithm which can divide this region into different sub-regions where each sub-region represents one kind of object. So similarly, if you talk about where actually we use, there are many applications of image segmentation, and in for medical diagnosis, we acquire lot of images, and one kind of image can be X-ray, and doctor visualize the X-ray, and through this X-ray, doctors are able to find out whether you are suffering from pneumonia or not, whether you are normal or you are suffering from COVID-19. And when we all were suffering from this disease, COVID-19, at that moment of time, the symptoms of COVID-19 were very much similar with the symptoms of pneumonia. And what should be the action plan? What kind of treatment should be given to the patient? It was very difficult to diagnose because symptoms were almost very similar. But through X-ray, it was possible to find out whether the person is suffering from pneumonia or COVID-19. Because the pattern associated with COVID-19 in the chest is different from the pattern associated with pneumonia. So here there is a use of image segmentation. Similarly, uh, we capture fundus image of your retina, and by identifying these vessels, doctors are able to diagnose different kind of disease, whether the person is suffering from some heart disease, or the person is diabetic, or the person is suffering from some other related disease. Okay, but one of the important process which is followed these days, that you try to segment this retina images, and these are vessels. So in the normal images there is particular width of the vessels, but when the person suffers from some disease, then the vessels are blocked. Okay, the width of the vessels get reduced. So by segmenting these vessels and by tracking these vessels, we are able to identify what kind of disease a person is suffering from. Similarly, sometimes many of us suffers from brain tumor, that there is a tumor in our brain. And before you do surgery, it is important to find out what is the shape of the tumor, what is the size of this tumor. You want to find out location of this your tumor, and then only doctors are able to precisely take out that tumor. Because if you are leaving some tumor region in the brain, then again you after few months you have to go through this process. While if you unnecessarily remove some good brain reason, then many functionalities will get affected. So the precise location along with the shape, size of the brain tumor is very important. And this can be done using medical image segmentation. Similarly, many brain related disease, you talk about Parkinson, you talk about Alzheimer's, you talk about dementia, you talk about your schizophrenia. Many diseases are identified based on analysis of the brain. Okay, and for all this, you require your medical image segmentation. Okay, before doctors can plan for surgery or plan some actions to take care of that disease. Okay. So what I told you, what is your image segmentation? So image is nothing but it is a region. So I'm saying, let's say the image region is described by a region R. I divide this region into many sub-regions. And let's say those sub-regions are R1, R2, Rn. Then what is the relationship between these Ris and R? So one of the fundamental important property is that when you combine these sub-regions, you should be able to recover the original region. So this is one property, means union of this sub-regions is equal to region R. And another important point is each region is a connected set. Means pixel values of every sub-region should be similar in some properties. Means either the color should be same or intensity should be same or texture should be same. Okay. And then another property is that intersection between two sub-region should be your empty set. Okay. So these are certain properties which are satisfied for your image segmentation. So while you suggest any image segmentation algorithm, you have to see that these properties are satisfied. So now I'll talk about one of the simplest method how we can do this image segmentation. So think about that you are given an image and it has only two kinds of object. Okay, and let's say one is your foreground object, another is your background object. So how to identify foreground object from background object? So image in digitally we store in terms of digital image, means image is represented in terms of a set of pixels. So when I say f of xy, so in image, in x row and in y column, f of xy represent what is the intensity of the image. So if it is an 8-bit image, then the intensity value can range from between 0 to 255. So I'm saying that there are only two kinds of pixels in the image. So a set of pixels having values more than a threshold, I'm saying forms an object, foreground object, and all pixels having values less than equal to that threshold, we say that that is your background object. So if you can choose correctly a threshold value, I can easily identify two objects, that is foreground object and background object. But if you have, let's say instead of two objects, you have three objects, then you have to choose two different thresholds. So I'm saying that if your intensity value is more than threshold 2, so that forms one region and I'll assign values, let's say A. While if it is between T1 and T2, all those pixels will be assigned values B. And if the intensity value is less than threshold T1, then it will be assigned value C. So means I am now assigning one of the three values A, B, C to the pixels. So all those pixels which are having values A, that will represent one kind of object, while all pixels having values B will be considered as another object, and all pixels having value C will be considered as third object. Now the question is how to choose these thresholds. Okay, so I'm suggesting one of the simplest method which is popularly used. Okay, and that's the name of this method is your Orzu method. So at present I'm describing for binary thresholding where I'm requiring only two objects. So what is the process? You start with any random values of threshold T, and then I will, based on this threshold T, I'll divide my regions into two sub-regions. One is region G1, another region is G2. So G1 will consist of all pixels having intensity value more than T, and G2 will form a set of pixels with values less than equal to T. So now you have two sub-regions. Now you recompute the group of pixels of G1 and similarly for G2. So let's say the mean value of intensity of G1 is M1 and for G2 is M2. I will recompute my new threshold T, which is the average of M1 plus M2. Now I'll use this new threshold and I'll repeat the steps 2, 3, and 4. And we can keep on repeating steps 2, 3, and 4 till you find that threshold does not change much. Okay. So it's a very simple method. Okay. So you just see that this is a fingerprint and it has various intensities in this. But using a threshold value 127, you see that I'm assigning only two kinds of values, 0 or 1. So all the pixels having value intensity 1 is representing background, and all pixels having value 0 is another kind of region, that is your foreground. Okay. So, but when the image has noise, then thresholding method is not effective. And also when you find that the size of the image is too big, then also there is a problem. And then you don't know how many objects you have. So because of this, you don't know how many thresholds you require. So thresholding method is a simple method, but it may not perform well. So now we'll be moving towards deep learning models, which are very popular these days, and it is giving much superior result in comparison to traditional methods like thresholding, k-means, fuzzy c-means, and your region splitting and merging. So there are many methods. Okay. So before understanding the main method of image segmentation, let's revisit one of the popular technique with which you may be aware, and that is your multi-layer perceptron. So it is an artificial neural network where what we talk about that in one layer you have a this is your input layer, hidden layer, and output layer. So the number of inputs, if it's let's say 100, then the number of nodes at the input layer will be 100. If you are solving 26 class classification problem, let's say you want to recognize English alphabet, then the number of nodes at the output layer should be 26. And in between input layer and output layer, you have hidden layer, and where you consider, let's say, NH number of nodes at this hidden layer. And every input node is connected to every node of hidden layer. And at every node of hidden layer, there is an activation function which changes the input to some other output. means transform the input to some another output. So let's say with the output coming out from these are y1, y2, y3, yn. These will go as an input to these nodes of the output layer. And then again you compute what is the net input coming out, reaching to these nodes. And based on these inputs, you give some output. And for here also, you use some kind of activation function. So how data flows? So let's say if the inputs are x1, x2, x3, xd, and let's say the weight is your wji between these two nodes. So what is the net input reaching to this node? We compute x1 into this weight plus x2 into this weight plus xj into this xi into this weight plus xd into this weight. And then there is some bias. Let's say this bias is wj0. So the net input reaching to this neuron is your net j. So I said that you'll be using some activation function. So let's say name of the activation function is, let's say f, f of net j. So the output at this node will be yj. So after input, the output at these nodes of the hidden layer are y1, y2, y3, yj. Now, at this point, you compute what is the net input. And the net input here will be your y1 into wk1 plus y2 into wk2 plus y3 into wk3 plus yn into wkn. And then again, there is some bias. We say wk0. So the net input reaching to this node, we say net k. And for a given input, there will be output. And let's say this is given by f of net k. So for a given input, you observe the output Z1, Z2, Z3, Zk. But actual output, and let's say this is T1, T2, T3, Tk. So since there is a difference between output observed by the machine and the output of the actual, you target output of the given sample. So you find out the difference, like you say, you compute the error. And the objective is to choose the weights in such a way that your error gets reduced. So how to reduce the error? So you may be knowing that there is a standard method, that is your gradient descent method. You say that W will be changed by delta W. And this delta W is nothing but minus eta del J by del W, where J is some error function. Okay. And eta is the learning rate. And this eta value is between 0 to 1. So based on this error, I can compute how much weight I should change. So we will be able to change, based on error, we'll change WKJ and then we'll change WJI. So now you'll arrive with a new set of weights. Again, you'll give the input. Again, you compute the output. If the output is different from the target output, you'll again change the weights. And this process will keep on going till you find that weights are not changing significantly. Okay. There are different kind of activation function people are using. People are talking about your step function, sine function, sigmoid function, ReLU function, LU function, TeLU functions. There are different kind of functions. People, your sine function. Okay. Now, in 1991, there was a research work which was suggested by Hornick, and which suggested that given your input data and its corresponding output, you can learn relationship between input and output, provided you choose a very large number of hidden nodes. And even if you choose one hidden layer, but by choosing sufficiently large number of hidden nodes, you can learn any relationship between input and output. So taking this as a basis, people thought of that can we actually learn it? So people have observed, yes. Theoretically, whatever was claimed, it was found that yes, this is possible. But now let's think about, you have images, and in each image you have characters, alphabet, English alphabet, A to Z, and you want to do correct handwritten character recognition. And the size of the image is 100 by 100. So the number of input nodes at the input layer will be how much? 100 into 100, that is 10,000 nodes will be there at the input layer. And since we are interested to recognize 26 different type of characters, the number of nodes at the output layer will be 26. And we have to choose sufficiently large number of nodes at the hidden layer. So let's say we choose 10 raised to the power 6 number of nodes at the hidden layer. Then how many connections you are going to have which you need to learn? 10 raised to the power 4 into 10 raised to the power 6. So the number of weights which you need to learn are too many. So you require large number of training samples. You require large computation power. Okay, so then what is the solution? So further, there was another research which talks about shallow versus deep. And according to this, if instead of one hidden layer, if I choose two hidden layer, the number of nodes of the hidden layer you can reduce, and still you can achieve the good classification accuracy. Then instead of two hidden layers, if you choose three hidden layers, the number of connection you can get reduced. And instead of three hidden layers, if you choose four hidden layers, further the number of connections will get reduced. And still you can get good accuracy. So that is the power of shallow versus deep. Means if you have deep architecture, if you have more number of layers in the network, you require lesser number of connections in comparison to shallow architecture where you require large number of connections for the same problem. Even though this research was there well published prior to 2006, still most of the researchers were using only one hidden layer or two hidden layers. You will not find any researcher using more than two hidden layers prior to 2000, 2001, 2002. Okay. But then there was a good contribution by two different researchers at two different labs. And both these researchers this year have been awarded Nobel Prize. Although the Nobel Prize has been given, Nobel Prize in physics, because there is no Nobel Prize for computer science. But because of the great contribution of these two different researchers, one was Hoffield, another is your Hilton. Okay, because these are the two great personality because of whom now there is a big revolution has taken place in terms of analyzing the data using deep learning models. And if you talk about one of the review published by MIT in 2013, across all science and technology, deep learning was considered one of the significant contribution among all science and technology discipline. And today we can really understand, or we can feel it, that yes, deep learning has penetrated everywhere. You talk about chat GPT, you talk about these days that you can get answer of any question, okay, and you can learn the relationship between any kind of data. We talk about these days we are generating artificial fake videos, fake images, So many applications are possible because of deep learning model. Okay, so let's see what is that great about this deep learning model and how it is different from traditional machine learning model. When you talk about traditional machine learning model, when I was describing your multi-layer perceptron, and I said that we are going to use the number of nodes at the input layer, so the number of inputs. So in traditional machine learning algorithm, it is important that you use right features which describe the data. If you are not using relevant features to describe the data, the learning between the data with your target will not be effective, will not be accurate. So one of the important stage in traditional machine learning is that given the data, you first extract relevant features and then you use some kind of predictive model. So you use support vector machine, you use decision tree, you use k nearest classifier, you use linear discriminant analysis method, you use Bayesian classifier. Okay, there are many methods. But if you are not representing the data with relevant set of features, the learning will not be appropriate and the prediction by these model will not be appropriate. But in deep learning, there is no requirement of separately finding out relevant features. This feature learning and predictions are integrated. Okay. Means parallelly both these things are happening. Means initially from the data you are learning features, using that features you are learning the prediction model, but then you keep on to improve the prediction model, you are refining your feature learning, and slowly you are learning better features, and then you are able to predict more accurately. Okay, so this is the difference in traditional machine learning approach. You have to use some method for extracting relevant features, while in deep learning, what we say, you give simple raw data and the model itself will learn appropriate features along with decision model. Okay, so at present, when if you are specific to images, the traditional machine learning approach to extract features are histogram of gradient. Then you have scale invariant feature transform method. You have GLCM method. You have GLOH method. You have RAFT method. Okay, so there are different kind of method. You use Gabor transform. You use wavelet transform to extract relevant features. But if you are not using correct feature extraction method, your your classification will not be good. Okay. So, but we will now talk about that how convolutional neural network will be able to learn features automatically. Okay. So I think you may have seen such kind of, when we were small, our parents has gifted us a toy box. And in that toy box, you were having blocks of different shapes, different colors, of different size. And what we used to do, we used to combine different blocks of different shape and size and color, and then we were able to successfully make butterfly or aeroplane or tank or a boy or a bird. Huh? So you have same set of blocks, but combining in a different ways of different shape, size, and color, we were able to make different kind of objects. So in convolutional neural network also, there is a need that you should be able to identify these building blocks. So if you take at present in traditional machine learning algorithm, how to extract these blocks? So you have your edge extraction. So let's say there is a one method that is Sobel operator. So if you use the convolution of the image with this Sobel operator, you are able to identify horizontal edge. Well, if you use this filter, you are able to identify vertical edge. So if in an image, you want to identify where are the horizontal edge, you use horizontal Sobel filter and do the convolution, you can tell where are the horizontal edge. You want to identify vertical edge, you convolve the image with vertical edge filter and you will be able to get this vertical edges present in the image. So I have demonstrated that if this is a picture and in this picture I want to identify where are the horizontal edge, I simply applied horizontal Sobel filter and I could locate the location of horizontal edge. And similarly, using vertical Sobel filter, I was able to locate where are the vertical edge present. So you think about that if you are given a set of images of different characters, let's say 0 to 9. So what are the building blocks required to make characters 0 to 9? One is your horizontal edge, another is your vertical edge, another is your this oval structure. So you need to learn these building blocks. And once you'll be able to learn these building blocks, then combining these building blocks, we can make different kind of characters. So you can see in these images, one of the common building block is vertical edge. Similarly, in this, another building block is horizontal edge. While there is another building block, you find there is a small circle. Okay. So by combining a small circle with vertical edge, I can make 6 and I can make 9 also. Similarly, by combining two small circles, I can make 8. And for making 4, you require 2 vertical edge of different lengths and 1 horizontal edge. But all these characters can be built with the help of the building blocks. And what are those building blocks? Horizontal edge, vertical edge, and oval structure. Okay. So I told you that in traditional methods, what we do? We can apply convolution with appropriate filter and we can get these blocks. But in convolutional neural network, we will be able to learn these blocks. Okay. And that I am going to describe. Okay. So you think about, you have images and you think about your human face. Your human face consists of different blocks. Well, what are those blocks? You require eyebrows, you require nose, you require eyes, you require lips, you require chin, you require some template of the face, you require hairs, you require your some color complexion. And you can, by combining them together, you can make a face. So what are the building blocks? Building blocks are eyebrows, eyes, nose, your lips, chin, your template of the face, color complexion, and hairs. So and when you talk about how your eyebrows are made, how your eyes are made, how your lips are made, so you will agree that by joining edges of different orientation, I can make eyebrows, I can make lips, I can make eyes, I can make nose. So what are the fundamental building blocks? The fundamental building blocks are edges of different orientations. And once we can identify these edges of different orientation, combining them together, we can make different objects of the face. And then by combining these faces, we can make faces of different humans. Okay. So for this, what we can do, you think about you are given an image and there is a need that I should be able to identify those building blocks. What we will do, I'll convolve this image with many filters. Let's say 6 filters. So that each filter can identify one kind of basic feature. Let's say that basic feature is horizontal edge. Another filter will identify vertical edge. Another filter will identify edge of 30 degree. Another filter will identify edge of 45 degree. Another filter will identify an edge of 75 degree. So, we use different filters to identify what are the different features present in the image. But machine has to learn these features. So you can randomly think about you choose random 6 filters, and these 6 filters we are going to learn from the training data. So you are given an image, you first convolve. I'll explain what do you mean by convolution for those people who do not know what is convolution. Then I'll describe what is subsampling. Okay, and then I'll be talking about how to compute output. So let me describe each one of this process one by one, because which is fundamental to understand a UNet model for segmentation. So let's say you are given a image and the pixel values are these, and I have 2 filters. At present, let's say I am taking filter 1. So what do you mean by convolution? Given this filter, I bring this filter and I align this filter with starting point of the image